Okay, now we move on to practical significance. This refers to the idea that the difference between the statistic and parameter may not be large enough to cause concern or be considered important. Let's look at an example. According to the American Community Survey, the mean travel time to work in Collin County, Texas is 27.6 minutes. The Department of Transportation reprogrammed all the traffic lights in Collin County in an attempt to reduce travel time. To determine whether there is evidence that travel time has decreased as a result of the reprogramming, the Department of Transportation obtains a random sample of 2,500 commuters, records their travel time to work, and finds a sample mean of 27.3 minutes with a standard deviation of 8.5 minutes. Does this result suggest that time travel has decreased at the alpha equaling 0.05 level of significance? Okay, like always, let's verify our conditions. Was it random? Yes, it was. Is it normally distributed? We have 2,500. That is definitely greater than 30. And then is 25 less than 5% of our population? Yes, it is. Step 1. Determine your null and alternative hypothesis. Again, we're working with mu. Okay, if you're not sure what number you're going to use, remember, this number is not going to be from the sample. So 27.3 and 8.5 is from the sample. Up here we have 27.6. And then for our alternative hypothesis, look at the question. It's asking, has it decreased? So that would be less than. And then copy that number down. Our alpha is 0.05. Step 3, find the test statistic and the p-value. We're working with stats. U sub 0 is 27.6. X bar is 27.3. X bar is from your sample. S is your sample standard deviation. N is our sample size. And we're looking for less than. T-value is negative 1.765. P-value is 0.0389. Compare your p-value to your alpha. It is less than that, so it is statistically significant. So we could write our conclusion. There is sufficient evidence at the alpha equaling 0.05 level of significance to conclude that the mean travel time to work has decreased. If it helps you, I circle the one we're going with because this means we reject the null. hypothesis. So we're going with this one. To me, that just helps visualize. So it was statistically significant. However, does it have practical significance? Let's read this overview. The p-value is 0.0389. Because the p-value is less than the level of significance, alpha equaling 0.05, we reject the null hypothesis that mu is equal to 27.6 minutes. There is sufficient evidence to conclude that the mean travel time to work has decreased. Okay, so there was sufficient evidence, but while the difference between 27.3 and 27.6 minutes is statistically significant, it has no practical meaning. After all, is 0.3 minutes, 18 seconds really going to make anyone feel better about his or her commute? You might be thinking, oh yes, I only travel 5 minutes, but remember, this person's going about a half hour long. So when you're going or driving 30 minutes or 27.6 minutes, 18 seconds is really not going to be that big of a factor. Large sample size can lead to results that are statistically significant, whereas the difference between the statistic and parameter in the null hypothesis is not enough to be considered practically significant. That is the end of this.